Welcome student to our channel. Students, we will continue the lecture of light in this session also. So now let's move to the topic. The first topic of this lecture will be mirror. Students, like we have already seen that the reflection is an optical phenomena that takes place when a ray of light strikes a polished reflecting surface. Now, the polished reflecting surface is nothing but mirror. Therefore, it becomes very important to understand the concept of mirror. Therefore, let us try to understand what mirror is and how many type of mirrors are there. Okay, so let's get started. Students, mirror can be defined as: mirror is a shiny polished object, especially glass, which reflects most of the rays of the light falling upon it. I think it will be clear to you all. And the most important feature of mirror is that it is polished on one side of it. Now the type of mirrors. There are generally two types of mirrors. The first is the plane mirror and the second is spherical mirror. Now students, we will talk about these two types of mirrors in great detail, but let's get started with the plane mirror first. Now, as you can see here that there is a diagram, in this diagram, as you can see here that there is an object Mn. That object has been polished. Students, see here this structure depicts the polish. This object Mn has been polished to this side. So this is the polished side of this object Mn, and this Mn is nothing but glass. So when a glass is polished on one side, it acts as a plane mirror, provided that it is a straight glass. Okay, now let us try to understand what are the properties of image formed by a plane mirror. Now I have explained you that this glass Mn is no more a glass. It has become a polished glass. Therefore, we can call it as a plane mirror. Now, suppose there is an object. When this object is placed in front of this plane mirror, what will happen? Try to conceptualize this through this diagram. Now see, when object is kept in front of any reflecting surface, the light rays from this object will radiate like this, and they will travel in almost all possible directions. But for our convenience, I have just taken few rays of lights. Here I have grouped these two rays and these two rays for my convenience, so that I can draw the whole diagram very easily. Okay, now see here that when the ray travel like this and strikes this Mn, that is the plane mirror, it will get reflected like this. Now what will happen next? See, it's quite definite, it's quite obvious that this object will be seen in this plane mirror. It means that this object will be casted inside this plane mirror. So how can I get this image? For this, I have to virtually produce back this dots and make them meet at a point, because image is only possible when at least two students, please keep this thing in your mind, that an image is only formed if at least two reflected ray either meets actually or appear to meet. So as you can see here, that since after reflection none of the rays appears to meet or actually meet, sorry, in this case none of the rays will meet. So what will happen? So in this case we have to make them meet at a point, and this is only possible if the rays are virtually produced to a single point, and this single point at which all the possible rays, reflected rays in fact, meet is known as the point of meeting, we can say the point of meeting. And this point of meeting or point of intersection of this reflected point of intersection of rays, at this point your virtual image is formed. This is known as virtual image, I, denoted as I. So what we have understood here, what we have conceptualized here is that when an object is placed in front of a plane mirror, a virtual image is formed. Moreover, there are certain properties of the image formed by a plane mirror. Let us take a quick look at that properties. Like you can see here, students, that the property of plane mirror, the first is a plane mirror always forms a virtual and erect image. Like here students, let us get back to the diagram. As you can see here, that the image which is formed by intersection of the reflected ray here forms a virtual image, as well as the image, since this image is virtual, it will be always an erect. So let me write here virtual and erect, virtual and erect image. Moreover, that image is of same size as the object. What does it mean? It means that the size of this image will be equal or same as that of the object. So this is also the property of the plane mirror. Okay, let's now move to the second property of the plane mirror. The second property is the distance of the image and that of the object is equal from the mirror. Now see, let's get back to the diagram once again. Students, see, let me suppose that this object O is located at a distance x, from this plane mirror. Now, when you measure this distance of image, this image from the plane mirror, you surprised to notice you will surprised to notice that this distance is equal to that of the distance of the object from the plane mirror. So this is the second property of the plane mirror, that is the distance of image and that of the object is equal from the mirror. I hope this is clear to you all. Okay, now move to the third point. The image so formed is laterally inverted. Now see, this term laterally inverted means whenever you stand in front of the plane mirror, in front of a plane mirror and raise your right hand, you will notice that your left hand is appears to rise, and this is what lateral inversion is. Or one very common example of lateral inversion is that when you suppose there is a plane mirror and you are writing B like this on a page and make this page stand in front of the plane mirror, you will notice here that this B is appear to you like this, in this manner. So as you can see here that the image appearance has changed now. This change in the appearance is known as laterally inversion, laterally inverted or lateral inversion. And I hope all these properties are clear. Okay students, let us try to understand the concept of spherical mirror. Now students, see, the spherical mirror can be considered to be composed from this spherical polished reflecting surface. What does it mean? This is nothing but you can consider that there is a polished reflecting surface which is spherical in shape. Now if you slice this spherical polished reflecting surface like this, you will get two parts or many parts as you like. But for our convenience, let us consider that I have sliced this spherical polished reflecting surface into two parts like this. These two small parts I have taken. Now it is up to me that how I polish these two surfaces. See, I can polish either of these two pieces in this fashion, in this manner. Like, see, if I polish this piece of this spherical polished reflecting surface like this, then this bulge part of this curvy piece like this is the reflecting side of this piece, and that of the depressed part, this depressed part is polished side. And similarly, if I polish this curved piece, this spherical piece in this manner, this depressed part of it will be the reflecting side and the bulge part of it will be polished side, and therefore I have got two type of the mirrors, the two type of spherical mirrors. The first one is the convex lens and the convex mirror, and the second is the concave mirror. This convex mirror is having the reflecting side as the bulge side, and in the case of concave mirror, the depressed side, this depressed side has the reflecting side. Okay, so I think the concept of the formation of these two, convex and the concave mirror, is clear to you all. Now let us try to form the images from these two spherical mirrors. Okay, now see the concave mirror. Let us try to explore this concave mirror. Now let me draw this concave mirror first. Now see, this is not the perfect concave mirror, but I'm trying to explain you with this poor diagram. Now see students, this this depressed side of this mirror is known as the reflecting side, the reflecting side.